Okay, good.
Okay.
Okay.
So
Here's where it gets
volume of
here.
the cone. 1/3 pi r squared h.
And volume is 1/3 pi r squared h.
None of them are constant. That's it. Boom.
Okay.
We're done.
So we're done. All right. The problem is I have a radius variable and I have a height variable.
But we have both.
I can't have that.
So we have to solve for one of them.
Yeah, I have to have, well, I want it in terms of h because I have a dh dt.
So let's
Divide the radius. The
subtract the volume and divide by.
Okay, y'all are like making.
What do y'all do?
Divide the
It's always
diameter.
for h.
So what I'm going to do is I'm going to say the radius to the height. Okay, it's a proportion, right? The radius of the whole cone
Yes.
is what?
5.
5. And the height of the whole cone?
15.
15. Okay.
We do
Yes.
math.
So 15R equals 5H. And I want it to be in terms of H. So
H is a
R equals, because I want,
I thought we're solving for h.
well, if we solve for H, then we're going to replace H with R.
1/3 h.
So divide, yes, and it's 1/3 H, or H over 3.
Cool. Now I plug that in.
So this is what's called a secondary equation. Sometimes you have a secondary equation that you can plug in that will help you get down to just one variable.
I have a question.
Yes.
How did we know to make a proportion? Why did we do a proportion?
Why do we do that?
Yeah.
Well, I mean, you could set it however you wanted to, really, but since you know the diameter, radius, and you know the height, we know those proportions are always going to be the same throughout.
Okay. So I just,
You know, as one gets bigger, the other one's getting bigger.
I was like, the only time I've done proportions is with triangles.
so like I just know
Well, think about, you know, cone is,
a triangle but circle.
yeah, but
And
3D.
3D.
In 3D.
Okay,
Triangle but circle.
Yeah, like 3D.
like this.
I'm going to replace R with 1/3 H.
It's bad.
So 1/9 h squared.
What the heck?
So 1/3 pi, 1/9 H squared.
Times
Yes.
h.
So that's 1/27 pi H cubed.
Cubing.
Cool. Beans.
Cool. Well, what if
This
you say
is
it like
more
that?
what-
Because I've been saying cubings for the past like 3 minutes.
She went, cool.
So-
beans.
So this is more like the problem that I gave you for bell work that I took away.
Okay.
Because you had to use 2 equations to figure it out.
Maybe you should tell Harvey that.
I already deleted it, so he'll never see it.
Oh, poor Harvey.
You'll see it tomorrow, Harvey.
I won't know the answer.
Okay, so dv dt, we're implicitly differentiating, equals 3/27, 1/9, very good, pi h squared dh dt.
So now it's going to be.
I don't know.
3/27.
Oh. Yes, I see.
Or 1/9, not 3/27.
Now the last one, substitute everything you know. All right. So dv dt equals 1/9 pi. Do we have h?
15.
That's the h of the whole thing.
I don't know.
No, we're solving for h.
No, we're solving for volume.
We're solving for dh.
We have what?
We just
DH is 1.2.
Okay,
We didn't solve.
I'm trying to talk to him. What?
We just have radius.
We just have radius. Okay, so, but we know we have a formula. Radius equals 1/3 h, right?
Oh, we know what DHBT is.
And
So
what's,
h is going to be
that is
3R.
true.
It's 1.2.
So h will be 3R.
Okay, so what's r?
1/3 inch.
2.
Up here, the radius.
5. That.
Oh,
We don't even have the radius.
oh, it says surface area.
Well, because they go with diameter.
The radius of the
Surface
surface.
area of the water. Oh, when the radius is, 2 inches. Okay, thank you. So 2 equals 1/3 h. So h is 6.
Fine.
What was dH dt?
1.2.
Calculator would be probably used here on this kind of problem.
We do have a fraction.
Miss King's.
Yes,
Miss King's brain would work better.
never. 4.8 pi. What's the units?
Inches cubed seconds.
Inches.
So inches cubed seconds.
Yeah, that's right. I said feet.
And we know it's cubic because it's volume.
Yeah.
Fun.
Now, maybe tomorrow,
Maybe.
I plan on, I'm going to finish this up. Yeah, that's what I'm going to do tomorrow.
Class is almost over.
No.
No.
Yeah, dude.
Well, it's
6
getting
minutes.
there.
We got 5 minutes.
But I'm going to finish this up tomorrow. And so if I didn't finish it today, so y'all can be working on the homework. But I'm not going to finish it today. Okay, so here's what the questions actually look like, which you have seen. They're not separated into these boxes.
I like the boxes.
The boxes are great, but it's unfortunate. Okay, a ladder is 25 feet long and it's leaning against the wall of the house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second.
It's negative. Yeah, it's pulled away.
But when did we get in
But then it'll be like this.
Okay, anyways, we know this,
That's constant.
it's constant, yep, at a rate.
That's going to be.
So I'm going to draw a little house here.
What would be?
Okay.
DH.
There's my house. There's my ladder.
Yeah.
There we go.
It's
Oh,
not
we made it.
Um, This ladder. Okay. Oops.
I don't know if I like the looking like a triangle.
So my ladder is being pulled out away from the base of the house. Is that right?
Yes.
Pulled away from the wall. Okay. So that's here. So since that's left or right, would you be okay with calling that dx dt?
Sure.
Awesome. So dx dt is 2 feet per second. We don't know what y is.
25.
We know the ladder is 25.
Or even a triangle.
You call it here. Come on.
We're trying to find how fast is the top of the ladder moving down.
So we're finding negative y.
Yeah, so we're not just y.
Negative x.
How fast.
I feel like we're trying to solve.
There you go. dy dt. That's a rate. Fast is a rate.
Mm-hmm.
That's what we're looking for. What are the units going to be on that?
Oh,
Feet, meters,
feet. Second.
Where do you guys come up with meters?
I don't know.
physics.
There's no meters here.
I'm sorry. All I ever say all the time is meters per second. Okay?
When the base of the ladder is 7 feet from the wall. Okay. So, the one thing that doesn't change is the 25. The rates, we've identified those, and the one we're wanting to find. What equation puts all these things together? What formula, sorry?
Hold on.
Pythagorean theorem.
There you go.
I had to think about
It's
that.
x squared plus y squared equals c squared.
But she also made a triangle.
Mhm.
So
Well, I mean, it is a triangle, though. You got a ladder coming out from the wall.
also that looks like a right angle. Let's do some like signs.
Yeah. C is constant,
25.
so that's just 25. X and Y, however, are not.
Tough.
So when I take the derivative of it, I get 2 x dx dt plus 2y dy dt.
Times 2 times 25.
And then it says, when the base of the ladder is 7 feet from the wall. So that's when x is 7.
So 14.
So x is 7. Dx dt was what?
2.
2. What's y?
We don't know. I really don't know.
The opposite of your.
How can I figure out y?
It's y over. It's the sine of y over 25. Wait, no, it's not. Wait, which
2
one?
over 25?
No, it'd be cosine.
Well, we only know. Oh wait, we know 2.
8.
I have to think.
That was
How could we figure it out if we don't know?
the same thing. wrong.
Pythagorean theorem, right?
Yes.
Oh,
That is a special right, or not special right triangle, but it is a Pythagorean triple.
That's why I said 8. I thought it was 8.
It's not. That's 8, 15, 17.
Yeah.
At least
Well,
I remembered one.
Do it the long way.
Hold on, I'm gonna guess.
I'm
Is it
not.
9?
no.
Is it a single digit or a double digit?
Do it. Work it out.
I'm gonna have to provide 9th grade brain can help me here. I think it's 9.
It's
I have to
not.
square root this, but I don't know how to square root.
It's
Yeah,
14. Negative 14.
It's not 14.
Down
Square root of 14.
You found it?
What
Why
was the
is
number?
this negative?
24.
24.
24.
Yeah, I do 25 times 25 minus 49. Find square root of the square root.
Okay, we'll stop there. What's that face for? Oh, okay.
Like, hold on, let me look at this.
Hey, Ashley, can you draw an apple?
I can draw dots in the center of your eyeball.
Thank you.
I don't even know what